Good evening, teacher. This time I will present my work in English on the topic of localization love of binary system. I apologize for exposing only due to personal problems that I mentioned earlier. I hope my presentation has a good develop to your liking. Introduction. The following presentation aims to address the issue of location loss in the pipeline system. We are focused on practical English throughout the lecture in order to take a more dynamic approach as we discuss fluid machines and we get out better in the English that we will use very often in of career. Localization laws and binding system. In any bind system in addition, the laws of low due to friction along the pipes there are mirror of localization laws due to first inlet or outlet of pipes, second sweat width or contractions, third curves, envelopes and other accessories. For valves open of partially closed. Fifth, uh, wind of gradual contractions. Loose or don't have to be small. For example, a partially closed valve can produce a greater pressure drop than a very long pipe. As the flow configurations in these elements is very complex, their theory extent is very poor. Losses are usually measured experimentally and correlate with flow parameters locations. Losses are generally given as a ratio between the pressure drop through the element and kinetic or velocity height on the fighting system. Loss coefficient K same H sub M um, on B squared on 2G. Um, a pipe can have several location laws as the terms are referring to velocity squared over 2 the of gravity. The sum of all of the team can be made if the diameter of the pipe is constant. Uh, are shown in the following equation. Note, however, that if a diameter changes, the loss must be 8 separate since squared. We also change the length of time from the equation is the total length of the pipe measured along its axis. The loads are immense when the opening is small, but it falls exponentially with the opening angle. the values of different manufacturers differ up to a factor of 2. Keep an mind that as usually in the figure that is based on the median velocity of the duct, not raised to the flow velocity is the pace trunk, the narrow valley orifice, and the curves or evolutions such as those in the figure always produce a pressure drop greater than Monday friction and strain conducts the use separation. How can we observe in the graph the factor K in relation to the Reynolds numbers? If if the intel is from a finite deposit and they name abrupt contractions between two different areas of the conduit in if the out is a large conduit, we call it a road winding. The laws of are indicated in the figure in the subset winding. They exert stress in the corner area with the circulation of their water zone is neglected, so that an analysis of the volume in control between the within sections and the int of separations sounds gives and theoretical laws of laws coefficient so EAB um, same same to 1 minus the diameter squared of b squared alt squared equal to uh, 8 over b squared same dot g. When the flow goes strong an expansion of gradual diffuse like the one snow in the following, the speed every time the pressure increases, the heat loss can be very important and the angle of the white too large due those separations of the flow in the walls and thin boundary layer like the figure also to lose a fully developed Intel profile the loss a combination of the pressure recovery of the actual flow plus the friction in the wall. The figures showed some correctionals the loss coefficient to be referring at dynamic height in the intellections and depending on the count of the ratio of diffuser in diameters, there is some dispersion between the date. Example: between two tanks water in pumped P same 1.94 as looked over feet roused at 3 and B saying 0.00011 feet squared same second and at the rate of 0.2 feet aroused at 3 same pardon sorry on second trunk at 2-inch diameter and 400 a foot long pipe while various intermediate elements are shown in the figure. The relative length of the tube is same 0.001. Calculate the power required for pulling. Uh, have the have in the example the graph for star solute the energy equation for the Stanley from between surface 2 and sorry 1 and 2 of the reservoirs is the show in the following equation, where H is the increasing in head due to pump as P1 same P2 yeah B1 same B2 same 0, solving for H age, we have the following equation. The average velocity associated with the flow is v equal v same cos on a equal 0.2 feet roused at 3 on second all on one on fourth for two on eh, 12, perdón, no me acuerdo cómo se dice 12, feet, feet, for feet, all on squared, uh, same 9.1 approximate feet on second. Let is now make a list of the coefficients of the localized loss uh, in the following graph, following values, and let's calculate the random numbers and the coefficient of region with the following equation uh, with on the saying 0.001. The Moody diagram guides us if uh, uh, sorry, same 0.02 to approximate. Substituting in the equation the head of pump is nets the pump must communicate the watt with a power of with the nets equation and nets using the conversion factor 1 HP equal to 50 50 100 feet for libra, no me acuerdo cómo se dice, for fuerza on seconds, we have been saying 4.2 HP assuming the answer, and assuming an approximate performance of 70 of pardon, 17 on 18 percentage, and the power consumed by the pump will be say 6 HP. Thank you.